This recording is for those who want to complete the Unit Geometry B Unit 6 sample work, vocabulary. Let's go ahead and get started. I'm starting with Unit 6, Lesson 1 for the keywords there. Okay. The first word is polyhedron. Polyhedron. Poly meaning many, hedron meaning face. Many faces. It is a 3D solid with flat surfaces. The most famous of being a cube. That is a hexahedron because it has 6 faces. Okay. Next word, vertex. Corner. The polyhedron here has 6 vertices, plural of vertex. Okay. Vertex, edge. Edge. A segment connecting vertices. So this is an example of an edge. Face. A flat surface. Bounded by, that means encircled by or surrounded by, bounded by edges. Okay, so this square is a face. And last word for this lesson, cross-sectional area, or cross-section. For this one, I always think of Fruit Ninja, the game that used to be made popular on the Wii game system. 2D shape of cutting. So, let's say I've got a cube and I cut it with a ninja sword. Okay, I might cut it this way. I might cut it through the midpoints of these 3 sides, and the 2D shape is a triangle. If I cut the corner off of a cube. Cross section. Okay, that's it for lesson 1. Lesson 2. Surface areas of prisms and cylinders. Okay. I have words like prism and cylinder and right cylinder and so forth. Let's start with prism. "3D shape formed by pulling a 2D shape through space." So, for example, this star pulled through space. When I first learned to draw as a kid, I loved to do this. Turn 2D shapes into 3D. That's an example of a prism, a star pulled through space. Okay, base. Now, base is a word that applies to all kinds of contexts, we're talking about the base in context of a prism. It is the 2D shape up here. So this star is the base. And you'll note that it has two bases. There is a base on the back too, and the base on the front. Altitude. Actually, I'm going to say height. It's the distance the base is pulled through. So in this example, this is the height. Okay, let's go with, I want to make sure we've got everything. Oh, lateral area. The side area, not the bases. So the lateral area is all this area. Lateral means side. Not the bases, not the two stars, but the sides, which is all rectangles. Okay, lateral area. Okay, we've got prism. Oh, we need right prism. That's when the height is perpendicular to the base. Okay? As opposed to, and it's almost easier to understand if you look at what's not a right prism, which is an oblique prism. When height is not perpendicular to the base. Example, we might pull a square or a rectangle through space at an angle other than a right angle. Okay, that would be an oblique prism. Okay, need more room, so let's go down here. And let's deal with cylinder. It's a 3D shape made by pulling a circle through space. Okay, here I'm going to use my drawing tools because we're going to refer to this repeatedly. So we pull a circle through space. And we get a prism. Not prison, a prism. Where do polyhedra go when they break the law? They go to prism. All right. Foam. Okay. So 3D shape made by pulling a circle through space. Prism. Okay. And all the words height and base and lateral area all apply to that as well. I'm not going to reference them. Okay. Let's see, what have we not done? Oh, right cylinder. Okay. It's a cylinder with height perpendicular to base. This is a right circular cylinder. As opposed to an oblique cylinder. It's a cylinder with height not perpendicular to the base. Okay, just a quick sketch here. So we pull at an angle through space. Okay, that would be an oblique cylinder. Okay, and we've done lateral area. We need to do surface area, and I think that's the last word on this lesson. This lesson had a lot of words. It is the area of covering. It's the sum of all faces of a polyhedron. Example, for a right rectangular prism with length, width, height, the formula for surface area is 2 times length, width plus length, height plus width, height. Okay, surface area. Lesson 3. Let's see if there's any new words here. We've got altitude, base, cone, height. So we're talking about a cone in a pyramid. All right. So I'm going to scroll up again. First word is pyramid. It has one base and comes to a point. To grab our star example, if it all came to a single point, that technically would be a pyramid. Okay? Okay, so pyramid. One base, and it comes to a point. Cone. One circular base. And comes to a point. Okay, let's draw a little more precisely here. So a cone looks like this, comes to a point. You can draw it right side up or upside down. It's kind of arbitrary which one's which. I'm drawing mine like an ice cream cone. Okay. So that's a cone. And there's a right cone and an oblique cone and a right pyramid and an oblique pyramid. So they don't have you define it, but they do have you define right cone. So let's do that. The height is perpendicular to the base. This is a right angle, so this is a right cone. Okay. All right, so base we've already defined. If the base, the word base is the shape pulled through space in a pyramid or in a cylinder and a prism. It's the same here. It's just that there's one base. Okay. Let's see, lateral area. Yeah, lateral area. We have lateral area of a cylinder and a prism, but we have lateral area here too. It's the side area. Okay, so the lateral area, the surface area of a right circular cone, is pi r squared plus pi rl. The pi rl is the lateral area. And the pi r squared is the base. Side area. Okay. All right. Height we've already defined. Let's see. Slant height. We need slant height. Distance along the side, along the lateral area. Between base and vertex. In this case, the slant height of the cone is right here, usually indicated by a letter L, slant height. Okay, and it applies to a pyramid as well. Okay, we've done altitude. Altitude refers to a triangle. Distance, perpendicular, between vertex, and base of a triangle. So here's a triangle. There's the altitude. Okay, we've done height, lateral area, pyramid, regular pyramid, right cone, slant, height, surface area we've done before, vertex we've done as well. All right, so that's lesson 3. Lesson 4. Composite space figure and volume. composite space figure and volume. Composite space figure. More than one solid. Together. Okay. For this, I'm going to draw a barn silo. It consists of a semicircle and a cylinder. You might also think of it as a bullet shape. But it's a composite space figure because it is made of more than one solid shape. You might draw a house, which has a pyramid for a roof and a rectangular prism for a bottom, for a base. Okay. Volume. It's the number of cubic units inside a solid. More easily, it is the space of filling as opposed to the area of covering. So in this case, the volume is 1/2 pi r squared h plus pi r squared big H. Okay, because that's the volume of the semicircle and the volume of the cylinder. All right. Volume, space of filling. Volumes of pyramids and cones, lesson 5. No new words. Surface area and volumes of spheres, lesson 6. Okay, we got a lot of words that deal with spheres. Well, looks like we're out of space here, so I'm going to go to a new slide. Lots of words in this unit. Okay. All right, sphere. All points equidistant. It's very similar to the definition of a circle. From one point. Only for a circle, it's on a flat surface, on a plane. This is in space. So we pick a point called the center of the sphere, and we plot every point that is a set distance away from the sphere. Okay. Now, for the sake of illustrating, I find it useful to draw a circle and then draw an ellipse with the front side solid and the back side dotted to represent a sphere. It gives it a 3D look without shading. You can shade it to look like a sphere. If you know your art class and know how a sphere is shaded. Okay, sphere. Okay, and some words that apply to sphere. radius, distance from center to any point on the sphere. So the distance from the center drawn to any point on the sphere. It's a radius. Okay. Center. Middle of a sphere. This is the center. We'll call this point O. Center. Diameter. Distance across a sphere through the center. Okay, so diameter. This purple line is the diameter. Great circle. It's a circle on a sphere, dividing it in half. Okay, so the equator is an example of a great circle. And there are infinite great circles on a sphere, but they have to, a great circle has to be a circle that contains the center of the sphere. So that's another one. It contains the center of the sphere. Okay. All right, so diameters. Okay, we haven't done the circumference. Distance around a great circle. So in this case, circumference is 2 pi r, or pi d. Distance around. Okay, sphere, radius of sphere, hemisphere. Oh, hemisphere, we haven't done that yet. Hemi means half. Okay, so half a sphere. Okay, and the way I usually draw a half a sphere is by drawing an ellipse with the backside dotted, and with the same circle drawing a half circle and indicating the center. That's a hemisphere. We live in the northern hemisphere of the Earth. Okay. Lesson 7, areas and volumes of solids. Similar solids. Similar solids. Same shape, but size can vary. Okay, so for example, I might have this rectangular prism and make a copy of it, just bigger. Okay, these are similar solids. Okay, and the symbol for similar is a wavy line. Okay, and then we have the project and the review. So that's all the words.